Okay, so let we proceed with the MATLAB. So we still use the previous block diagram that you have made for passive suspension. So here I just make an improvement. So I just combine for the KS and CS. I just simplify it, so become like this. So in order for us to modify our block diagram from passive into active, so the concept is we need to build some subsystem. So if you see here, we need to build our plant. So in the MATLAB, we call it as a subsystem, and then we apply the controller. So for the first one, we put a P controller first. Okay, this one. And then the second one, we put a PI controller. And then the last one, we put the PID controller. Okay, I will show you on how to do the subsystem first. We go into our MATLAB here. So into subsystem, we need to make sure this one need to be eliminated first. Okay, go to your library, and then you can go into commonly used block. So we have a subsystem here. So just write the subsystem first. Okay, so you see here there is a one input and also one output. So if I double click here, you can see this kind of a block diagram into a subsystem. Right now, as I highlighted here, you under a subsystem. So if you want to go back into the previous block diagram, into the main diagram, you can click here. So you come back into the main block diagram here. Okay. If you see our lab sheet here, so we need to have a constant here. So in this case, we put damper as our constant. So we need to take up our constant from our subsystem. So how to take up? Okay, here. So here our damper here. So I need to put a product. So the product, this one, under commonly used block. Okay, you just write here. Okay. And then you just delete the old one. Okay, this one I just move up a little bit. Okay. So this one I connect to here. This one I connect to this one. Okay, so here is the input for damper. So go to our library. So here we have an input and also output. So for this time being, we put an input first. So I drag the input. Okay, and then I connect this one to this one. Okay, so once we have an input here, mean an input here, so we must have an output here. So the output, go to your library, and then we choose an output. So we put here, we want to study about the displacement of suspension and also the acceleration. So we have output 1 and also the output 2 here. So I just copy this one this one as output 2, output 1 for displacement. Okay, so I suggest you to color in order for us to see clearly the block diagram. So how to color? Okay, you can right click and then go into the format and then go for the background color, then change. This one is up to you, what color that you like. So I choose input is a green color, and then the output for displacement I put the blue color, and then this one I put orange color. Orange. Alright. See, so this passive block diagram, we want to into our subsystem here. So inside here, okay, I just delete first, okay, and then I go back into my main block diagram. Okay, so I just cut this one. Okay, I highlight first on, and then I cut, and then I go into my subsystem here, and then I paste, Control V. Okay, make it bigger. So right now we have one input, okay, which is the green color, and then we have two output here, which is blue and orange color. So if we go back into the main block diagram, here you see you have one input and two output. So this time you can save this file, save as, okay. Let's say you save as a suspension control model. Okay. Save. I set another one. Let's go one. Okay, so once you rename inside here, so we have done for this plant. Okay, so what we need to do, we add the P controller and also the sum and also the constant here. Okay, and then we want to see the output, the graph here. So how we do that? So we put a P controller, go to your library. P is a proportional, so we use a gain. Use gain. Sorry, this one we make as a base model. Base model. Okay, and then this one we make as a proportional controller. Because why I put a two base model and proportional controller, this is for comparison of the data in the graph data. So this one you can copy and then paste. This one for a proportional controller. So for the base model, I need to create an input for this one. So I go to the constant. Constant, commonly used block. Constant. So this value is belong as 1100. Okay, because why? You see here the damper, the damper changed to 1000. So this one we change to 1000. Just follow your lab sheet requirement. So this one 1000. Okay, so this one is a CS. So just double check the value inside your subsystem here. So MS is 150. So this one is 150. I change. And then next one, MU is 30. So change to 30. Okay, the KS 32,700. This one I change 37,500. Okay, next one CS 1000 already changed, and then KT is 100. Okay, set 100, and then okay, this one is 0.05. The value here 0.05. Okay, everything is good. Okay, I'll go back. So this one I delete. So I just copy back this one. Copy. Okay, so this one we want to see the graph. So we put a plot here. Scope, put a scope. So we have a 4 scope. So this one connect to this one. This one we tag to this one. This one we tag this one. Then this one we tag this one. Okay. So we refer back to our concept here. So we done the controller, the P controller here. P controller, how much the value? We refer here. The P controller is 3. So it's 3. Okay. So I need to create a sum here. Sum. If you don't find, you just type here sum. Okay, I choose this one. Okay, so we need to tag here. Okay, and then the constant maintain. Okay, so the model here we see we need to look back. We have a loop here. So go to our magnet. This one. So which one we want to look back is ZS here, number 1. So number 1 we need to look back. So here. Okay. I move a little bit here. So this one, the proportional controller, we use a P controller here into our system. Okay, so once we done this one, we can run our model first. So everything is good. So basically, usually we want to compare the result of the graph. So how we want to do a comparison? We must put some block diagram in order for them to cover the data, to combine the data. So in order to do that, so I use marks. So I search this one, marks. Okay, I put marks. Use this one, marks. Just make it smaller. So I want to study for the displacement first. So I tap this one into this one, and then this one into this one. And then I want to see the graph here. Like this one. Then once we put some block diagram, we need to rerun again our model. Okay, so we can check the data plot here. So you can see from here. So the yellow color is belong to the base model. Okay, and then the blue color is belong to a proportional controller. So from this graph, you can see some improvement. The overshoot height become lower for the professional, and the settling time become shorter. So this one is a good indication if we use a proportional controller. So later we need to add on the controller such as a PI, and then after that we last one we use a PID controller, and then we need to study the graph. So either it become more better or worse. Okay. So before we proceed to for the PI and also the PID, I want to share one more thing with you all. So if you see here is our input is numbering, number 1, and our output is number 1 and number 2. So actually we can change into our desired name. So how to do that? You click here, and then for the input, let's say here this one, you can write, then show block name. So this one you can rename as a input. Okay, same to this one. This one you can rename into as a ZS. ZS. Then this one, block name. Okay, I change into ZS double dot. Okay, so once we change this one, we go into our main block diagram. Automatically it will change. So this one. Okay, so next one we continue to do for PI controller. Okay, so I just put a name here, PI controller. Okay, so this one I just copy. Okay. So this one delete. Okay, so this one is a for P, and then we need to add on another one is integral. So this one, and then I put a integration. So go to our library, come and use block. Okay, integration. So there's integration. Integral. Integration. Integrator. So I choose this one and then put here integrator. So the value for I, we refer to our left sheet. So the KP is 5 and KI is 0.1. So we change this one into 5. So this one is 0.5. Sorry, 0.1. So we integrate and then we go back here. Okay. And then again we need to put our scope. Scope. Copy. Yes. I want to study for the first one. This one. And then the one. This one. Okay. Then I want to marks. So let's say if you want to add on under the same graph, okay, you can double click this one and then you add the number of input. Okay, so from here I type here. Okay, we have a PI controller here. So I run this model. Okay, so I can check the result here. So the new one is the red color. If you see here, the overshoot a little bit higher, but then the settling time much more better. You see here in the graph, much more better. So they have a pro and cons for each controller. The last one you can add for a PID controller. So PID controllers, I copy from this one. This one. So I put the system PID controller. Okay, so I need to add another element which is a derivative. Okay, so this one I copy. Okay, so the value for D is 0.05. Okay, 0.05. So KP change to 6. So change to 6. Okay, this one is maintained. This one I change to 0.05. Just make it bigger. Double check 6 0.05. KI 0.05. 0.05. Okay, sorry, so this one is actually 0.05. Double check. Okay. So the here we need to put a derivative. Derivative. This one, derivative. So I need to okay, so again the scope I put one scope here and then another one for the ZS double dot. So I want to compare the graph. So this 4 graph I need to compare all together. So I double click, I add another one. Okay, so I make it bigger and then I tag to here. So once you're done, okay, so you can click run again. Right? Okay, should be in this we have 4 graph. Okay? So I double click. Okay, the latest one is the green line color here. Okay, so I just make it bigger. Okay, this one, the latest one, PID controller. See the overshoot almost 0.08. Then the settling time. Sorry. This one. Okay. So you can see the difference here. Okay, the PID controller, the yellow, sorry, the green line color here. So the settling time is almost same like the P controller. Okay, that's it for the step function input. Okay, so by using the same model here, inside the subsystem, okay, you can change into the sine function, and after that you change into sequence times repeating sequence. Okay. Alright. Sorry. Okay. That's all from me. So hopefully you can understand this video. So at the end you can submit your report according to due date in the ULEN. Okay, so that's all from me. Thank you. Wait, sorry, I have some correction here in my block diagram. So actually, when you do like this, when we go into our subsystem here, so you see one input is floating. So this one is not proper way to do it. So how to settle this problem? Actually, okay, we need to add up the block diagram, addition block diagram, this one, make operation add. Okay, so this one I delete. So inside the subsystem also I delete. Then from here, okay, I put this one here. This one I tag to here. Okay, so this one tag to here. Okay, So just move a little bit to make it look more proper. So same goes for PID controller. So this one inside the output, the input become 3, so I delete. This one also I delete. So here we need to add the addition block diagram. Copy this. Okay, so this one delete. Okay. And then again we have a 3 addition. So double click here and then we add another one. Okay, so I tap here. This one I tap here. Okay, so from here we tap here. So once complete this one, so we rerun again. Okay, so everything's good. So double check your graph. Okay, more proper way lah. Okay, so once you done this one, as usual, your graph need to be plotted into window command. As I teach you, as I taught you in the previous lab session. So hopefully everything is clear. So sorry for my bad just now. So thank you again.